Hi everyone. So in the previous several videos, we've talked about different aspects of 2x2 systems of linear equations. So to end the week, I want to spend some time going over some examples of 3x3 systems of linear equations. Now these look really intimidating and there are a lot of steps to them, but they really aren't that bad if you're able to break them down into smaller problems. And that's actually the strategy you're going to take with solving any of these. Okay, so the goal with these is that you want to start by trying to reduce this system of three equations in three variables. In this case, we have x, y, and z for each of these. We're going to see if we can break this down into a system of 2x2, or a 2x2 system, and then solve that using ways that we have learned thus far. Okay. And one of the nice parts about these is that there's lots of ways of going about it. So if you feel like you're stronger with one way of solving systems of equations, you can approach it that way. If you're stronger with another, you can approach it that way. So you're not as quite as limited. The more equations you get, sometimes the more freedom you have. Okay, so let's go ahead and get started. So if we want to reduce this to a system, a 2x2 system, as opposed to a 3x3 system, where we have two equations and two variables, rather than a three equations and three variables, we need to pick a variable that we want to eliminate, okay? So when I look at this, I'm thinking we can go ahead and eliminate the y variable from equation 1 and 2. And as a matter of fact, let's actually just label these equations with numbers. Okay, and the reason here is we're going to see, that'll make it easier to organize what we're doing here. Okay, so we're going to start by adding equation 1 to equation 2. Okay, so if we add equation 1 to equation 2, we'll have negative x plus y plus 2z is equal to negative 3. We're going to add 3x minus y plus z equals negative 2. So if we add these together, here we'll have negative x plus 3x. That's going to give us 2x. Y plus negative y gives us 0. And then we have 2z plus z is going to give us 3z. And negative 3 plus negative 2 is going to give us negative 5. So we have, simplify it, this becomes 2x plus 3z equals negative 5. Okay, so now we have an equation with just two variables. We have x and z. So now what we have to do is we have to go back and we have to eliminate the y variable from two other equations, like some combination of two other equations in our initial 3x3 system. So we added 1 to 2, so we eliminated it somehow with 1 and 2. Now we have to eliminate y by either choosing 1 and 3 or 2 and 3. Okay, so I'm thinking because the y is positive here in equation 1 and it's negative 3 here in equation 3, we are going to go ahead and choose equations 1 and 3. But what we're going to do is we're going to multiply equation 1 by 3 so that we can turn this y into a positive 3y. Okay, so we're going to have 3 times equation 1 plus equation 3. Okay, so if we multiply equation 1 by 3, we will get negative 3x plus 3y plus 6z, and that's going to be equal to negative 9. Okay, and now we're going to add equation 3 to it. So here we have 2x minus 3y minus 4z is equal to 1. Okay, so we have negative 3x plus 2x. That's going to give us negative x. Okay, now we have 3y plus negative 3y gives us 0. And then 6z plus a negative 4z is going to give us 2z. And negative 9 plus 1 is going to give us negative 8. Okay, so this equation is going to become negative x plus 2z is equal to negative 8. Okay, so now we have a 2x2 system where we have 2x plus 3z equals negative 5, and we have negative x plus 2z equals negative 8. And now what we can do is we can solve this like we would any other 2 by 2 system. And that's going to allow us to find two of the variables. And if we have two of the variables, we can take those values and plug it back into any of our three equations that we have up here. So let's go ahead and solve this one. So I'm thinking the first step is to maybe multiply the second equation here by 2. Okay, so if we multiply this by 2, this is going to become, we'll have 2x plus 3z equals negative 5, and we'll have negative 2x plus 4z is equal to negative 16. So if we add these together, we'll have 2x and negative x, that's 0. 3z plus 4z is going to give us 7z. And negative 5 plus negative 16 is going to give us negative 21. So this is going to become 7z is equal to negative 21. Okay, so we can divide both sides by 7. And we'll get that z is equal to negative 3. Okay, so z is equal to negative 3. And now what we can do is we can take this and plug it back into any of our initial equations. I'm going to go with the second equation here. So that'll give us negative x plus 2 times negative 3 equals negative 8. Or we have negative x should be minus 6 equals negative 8. If we add 6 to both sides, move this down. If we add 6 to both sides, we get negative x is equal to negative 2, and that's going to give us that x is just equal to 2. So here we have x is equal to 2, we have z is equal to negative 3. And now our last step is to take these two values and plug them into any of our initial three equations up here. Okay? So I'm going to say let's plug it into the first equation. I don't know if any of them are particularly better, but that's going to give us as negative x plus y. So we'll have negative 2 plus y plus 2 times negative 3 is equal to negative 3. Okay? So now we have negative 2. We have negative 2 plus y minus 6 equals negative 3. Let's move these equations down for our next problem. Okay. If we combine like terms, we'll end up with negative 8 plus y equals negative 3. So now we can add 8 to both sides, and we'll get that y is equal to 5. So our final answer is going to be x equals 2. X equals 2, y equals 5, and z equals negative 3. Okay? Or you can express this as the point 2, 5, negative 3. This would also be a valid way of describing this. Because what we're seeing here is we're actually seeing the point where these three lines intersect with each other. Okay?